I'm reading from the geography textbook starting on page G73. Geographers are interested in patterns on the Earth. They use the arrangement of cities, landforms, or river systems to help them identify unique regions. A few pages back, you learned that most active volcanoes are located at plate boundaries, especially around the Pacific Ring of Fire. In this section, you will focus on more landform patterns found on many of the continents. These include shield regions of ancient rocks, plains and lowlands, and fold mountain chains. You will also learn that both rock age and rock type have been important in creating different landform patterns. Most of the examples in this section will highlight major North American landform regions. Over here on the side, we see some different landform patterns: active volcanoes, ancient shields, fold mountains, plains, and lowlands. And here's pictures of those four: an active volcano, an ancient shield region, fold mountains, and plains and lowlands. During the Earth's 4.6 billion year history, land masses have been built up and then worn away many times. Scottish geologist James Hutton first advanced this idea in 1785. But most scholars rejected it. At the time, scientists thought the Earth was only 6,000 years old, but this was too little time for so much change to have happened. German geographer Alfred Wegener was another landform pioneer. In 1912, he proposed that all of the continents were once joined together in one huge landmass named Pangaea. His theory was also criticized, but is now considered a key to understanding landform patterns. The modern theory of plate tectonics is built upon Wegener's pioneering work. And for words matter here, plate tectonics, the theory that all the continents were once joined together and are gradually drifting apart. And we saw those in our previous videos where the plates kind of float on top of the magma. Shield regions. Pangaea was built around old shield regions. These regions were created by widespread volcanic activity billions of years before. They are largely composed of igneous rock, that is, solidified magma. Later, heat and pressure altered some parts of these old shield regions. This formed metamorphic rock or changed rock. As Pangaea broke apart, the shield regions were scattered across the Earth as the core of the continents. Today, they are heavily worn and carved by the relentless forces of erosion, water, ice, and wind. Ancient shields, such as the Canadian Shield, often have widespread areas of bare rock. We can see some of those, especially toward, past Brockville and towards Kingston. There's areas of the Canadian Shield you can see along the highway. Which continents can you recognize in ancient Pangaea? And metamorphic rock shows the effects of heat and pressure from within the Earth. A few words before I read this next section. Igneous rock, that's solidified magma from inside the Earth. Metamorphic rock is rock that has been changed. And sedimentary rock, thick beds of sediment that have slowly solidified into rock. The erosion of the shield regions created the rest of each continent. Rivers and glaciers carried eroded material, called sediment, into ancient seas. There it accumulated into thick beds that slowly solidified into sedimentary rock. New land emerged around the ancient shields as the seas filled in. These plains and lowlands are underlaid by horizontal layers of sedimentary rock. Plains are broad areas of level land, such as the Great Plains region of central North America. Lowlands are plains located along coastlines. For example, the Great Lakes St. Lawrence lowlands would be where we live. Fold mountain regions. Look at a relief map of the world, and you will see an amazing landform pattern. Great mountain chains cross the continents in bands. One chain runs the entire length of North America and South America, continuing into Antarctica. Another crosses Europe and Asia from east to west. These are the fold mountain systems of the world, huge crumpled ridges where plates collide. You see how the fold mountains form. the layers of rock, and that one plate goes down, those layers begin to fold, and we've got the mountains being produced. Fold mountains have been built from thick layers of sedimentary rock deposited in ocean basins. As currents in the mantle drag plates together, these layers are arched up in parallel ridges like a wrinkled carpet. Of course, rock cannot bend much. Frequently, the folds snap, causing earthquakes and movement along cracks called faults. As a result, the sedimentary layers have sometimes been heaved up and stand on end. The pressure of extreme folding has created areas of metamorphic rock in some fold mountain regions. These great mountain systems form distinctive regions. They divide the flow of rivers. Their elevation causes clearly identified climate regions, which in turn create conditions for unique communities of plants and animals. In short, fold mountain patterns form ecozones. And then the next page is this map of North America. And we can see the height here in the legend. So the darker brown is the highest here within the Rocky Mountains. And then the lowest areas are the dark green. So that's the sea level right around the edges of the coast. So we live on these lower levels here along the St. Lawrence River. And the Rocky Mountains are formed from sedimentary rock folded and thrust up by the collision of plates. Two coastal mountain regions, such as Sierra Madre, have igneous and metamorphic rock from volcanic activity. And that's down here in Mexico. And then number 3 is up here, the Canadian Shield by Hudson's Bay. The Canadian Shield is the core of the continent, an ancient region of igneous and metamorphic rock. And number 4 is the Great Plains. So we're looking at like Saskatchewan and Manitoba. The undisturbed sedimentary rocks of the Great Plain regions were deposited in ancient seas. And then 5 is the Appalachian Mountains are made of sedimentary rock folded by plate collision and heavily eroded. The Appalachian Mountains are here. Alrighty, that's it.